How was that possible? How did 8 people manage to stop an F1? How did a man slow down the machine? To begin to find out, you must know what an isometric movement is. This is a movement where two equal forces face each other, creating a balance between objects. By knowing this, we can say that the forces between the F1 and the scrum are almost identical, so that no one can take advantage. We can also say that if we find the strength of one of the objects, we will also have the force of the other. Let's start with the F1. This RV8 weighed about 800 kilograms. It reached 335 kilometers per hour and it had 750 horsepower. However, these horsepower units are reduced due to the transmission from the engine to the wheels, the resistance of the soil to growing the car, and to the wheel slippage produced. Now, by knowing this data, we can apply Newton's second law that states that force equals mass times acceleration. The mass is 800 kilos and this car reaches 3035 kilometers per hour. The equivalent will be 27.8 meters per second and 16.4 meters per second square. This measure is the acceleration and we will use it in the calculation. As stated above, force equals mass times acceleration. 800 kilograms multiplied by 16.4 meters per second square is equal to 13,120 newtons or 1,338 kilos of force. The same force used to give a piggyback to a rhino or the bite of a crocodile that clash between two oxen or a collision at 50 kilometers per hour. To stop this machine, each rocking player had to generate 2,484 newtons or 253 kilos of force. Those who were paying attention will realize that 8 times 2,484 is bigger than 30,120. This is because there are losses of strength in the scrum. According to a study in New Zealand, the strength of the scrum is the 60% of the sum of the individual forces. This is because their forces generated and not used in the push. A clear example of this is the pier grip. Another reason for the losses of strength is the angle of the push. When the scrum pushes forward, not all players push in that direction, and not all push with both shoulders. An example of this are the back rows. The flankers push at an angle and with one shoulder, while the 8 sometimes doesn't even push. It is not consistent that the players only contribute with the 20% of the force of the scrum. Later, the first row generates 38% of the force. This is because the hooker is pushing forward with both shoulders, while the loose head prop is pushing with one shoulder and the tight head is pushing at a certain angle. And finally, the second row. These two players are the ones that generate more force, with the 42% of it. It is probably due to both players pushing with the two shoulders. In the past, the scrum could take advantage of the 1,360 kilos generated in the set, but a few years ago, the World Rugby decided to change the rules of the scrum to reduce and prevent injuries. The biggest change was the reduction of the distance between packs, pulling speed, and, by consequence, the input of force. Now, the entry of a scrum generates 1,106 kilos of force, which may seem low, but is 200 kilos more than a knockout punch. But then, how was possible that the scrum stopped the F1? It is that the scrum has a secret weapon, the slippage of the F1. The slippage is the ratio between the tangential velocity of the wheel and the vehicle speed. In other words, it's the relationship between the rotating speed of the wheel and the speed of the car itself. The greater the difference between these two, more slippage there is, and the vehicle can even become immobile. As we can see in the video, the F1 starts to move forward a little, but quickly the slippage stepped into action to help the rivals and stop the car. Later, the Scrum will start his push and, as in a game, lead the Red Bull back a little. And like that, with a lot of gym, a good diet, years of training, and a little bit of slippage, 8 men of flesh and bone stop the most powerful of the machines.